So I'll say good evening to everyone. This is the Front Range 6 meter group. And tonight we have Carl, K9LA. Carl, just a little background on quick on him is he was licensed in 1961, and his interest in propagation went all the way back to college days in the 60s and early 70s. That's about the same time I was in college. And Carl also has an amateur radio propagation website, K9LA.us, which is pretty interesting, lots of information there for you all. So tonight, Carl will address the topic of solar indices and how weather can affect VHF propagation. So with all of that there, I'm going to throw it over to you, Carl.
Okay, Paul, thank you very much. Here I'm going to talk to a whole bunch of 6 meter operators about 6 meter propagation. Wow. Oh, well, if you guys want to chime in, that's fine with me. Because just last year, I learned how to spell propagation. So, and luckily I stayed in the Holiday Inn last night, so I think I can get through this. I see that Lance, W7GJ's here, and Jim, K5ND. I think I talked to you guys in June of 2020, and I'm pretty sure I referenced Jim's book on 6 meters. So again, go look at that. There's like a lot of good information in there. So I'm Carl, K9LA, in Fort Wayne, Indiana, up in the northeast corner of the state. Not too far from Michigan, not too far from Ohio. And let me get my screen up here. Let's see, special. Come I get 2 here? Where that came from? Share. Let me get it on full screen. I hope.
I'm not seeing anything here yet. Oh, there it is.
Here you go.
No, it usually takes 2 clicks to get it onto full screen for some reason. I don't know what's going on, but here it is. And what I titled it was How Space Weather and Terrestrial Weather Affects 6 meter Sporadic E, although I thought I'd throw in a little tropospheric stuff too. I had thought about talking about meteor scatter and short path summer solstice propagation per JE1BMJ, but then, that thing had run too long. So it got enough here for what I'm going to talk about. So we're going to just review the important solar indices and talk about space weather and 6 meter propagation, talk about F2, talk about Sporadic E, and also Transequatorial. And then we'll get into terrestrial weather and 6 meter propagation. Talk about tropospheric ducting and also Sporadic E. And then I thought I'd take a really quick look at solar cycle 25. Just got 3 slides, so it's going to be pretty quick. And it's news. I don't know if it's good news or bad news yet, but whatever. Okay, here are the indices that I think are important. And what I'm going to use is the N0NBH banner that you find a lot of places on the web. For example, at qrz.com, I pulled that this morning. And this slide and the next slide talks about the indices that I think are important. Then we'll get into why they're important. SFI, of course, is the latest 10.7 meter solar flux index this morning, or today at 78. So that ain't bad. It's better than 65 or 70. SN's today's sunspot number 47. That's pretty good. We've had a good week or so of sunspot activity. We'll see how it continues. A is yesterday's A index. It's the average of the 8 3-hour indices, and it tells how active the Earth's magnetic field is. Usually when the Earth's magnetic field gets active, the F2 region has a problem. The K index is the current 3-hour index. Again, it's activity of the magnetic field. The PLNTRY means they're planetary indexes. They're from a bunch of observatories worldwide. So it's kind of looking at the Earth's magnetic field over the whole Earth. X-ray is the background radiation at 0.1 to 0.8 nanometers. It's pretty short wavelengths, and that wavelength can get down to the D region and induce ionization during the day. Solar flares, that's, radiation in 0.1 to 0.8 and also 1 to 10 nanometers. They're classified as from A, which is the smallest, to B to C to M to X, which is the largest, and it's a logarithmic scale. So each step from A to B is a factor of 10. So things X-class X-ray flares can get very big and do lots of interesting stuff. 304A, that's 304 angstroms, which is equivalent to 30.4 nanometers. That's extreme ultraviolet radiation. And 26 to 34 nanometers is responsible for about 60% of the F2 region. So this is a pretty direct indication of F2 region ionization. And that's good that's in the N0NBH banner. Continuing on, we go down to some more measurements. PTN FLX is the proton density in the solar wind. It's given in that electron volt range. It's measured in several different ranges. ELC FLX is the electron density in the solar wind in that range of electron volts. Aurora is a scaled power from 1 to 10, and it says how much power is coming into the auroral zone from precipitating electrons. It loosely correlates to the K index. AUR lat is the lowest latitude impacted by aurora. So the higher, the more active the Earth's magnetic field is. BZ is the strength and the direction. Direction is plus or minus of the interplanetary magnetic field. That's not the impossible mission force. So I just want to make sure that's clear. And the BZ component of the interplanetary magnetic field is perpendicular to the ecliptic. In other words, the plane that the Earth goes around the sun. So BE is pretty much north-south, just like our magnetic field is north-south. Okay, SW is solar wind speed in kilometers per second. Quiet time's around 400. And the MUF US Boulder is the maximum usable frequency in megahertz at the Boulder ionosonde. It's for a 3,000 kilometer path with Boulder at the midpoint. So that's a good indication of what's going on. So let's go back to that previous page. And we saw that the solar flux was 78, sunspot was 47. We'll talk about what those numbers mean for the higher bands in 6 meters. A is 8, K is 1. Things are pretty quiet. X-ray, the background X-ray flux is about A 7.4, so it's the lowest category of X-ray flux, which means things are kind of quiet. 304A, that's the EUV is 99. We'll talk about that a little bit later too. Let's go forward again. The PTN flux and the ELC flux are given, which I don't think they correlate a lot to what's going on, but I'll talk a little bit about that later. Aurora Latitude was 67.5, so it's not very low, and that kind of is commensurate with the fact that K is 1. BZ is 1, and solar wind is 345.6 kilometers per second. So it's a little bit quieter than average, and that's pretty good. In the bottom left are some subjective HF conditions for the HF bands. On the top right are VHF conditions, Aurora. and Sporadic E in Europe and North America. So it gives a, you know, a quick summary of what may be happening on those VHF bands. And there's a current image of the sun in extreme ultraviolet. When we see lots of white in that picture, that means things are going good, and there's probably lots of EUV to make the ionosphere strong. So some general statements about those parameters. When we're at solar minimum, which we're still kind of down there, when the solar flux is, you know, 65 to 70, and when the sunspot number is 0, there's still enough extreme ultraviolet from the sun to allow worldwide QSOs on 20 meters, and of course, lower frequencies than 20 meters. So these parameters, when they're high enough, can indicate worldwide openings on frequencies higher than 20 meters, and now it goes all the way up to 6 meters too. So those are pretty good things to focus on, and we will a little bit later. All those, the next bullet has the parameters that tell us how active the Earth's magnetic field might be, which means perhaps how much the F2 region is degraded. Okay. The X-ray and the PTN flux, that can indicate that a big solar flare happened, and that may tell us that the F2 region can be screwed up some more. Oops, there we go. Okay, let's talk about space weather and 6 meter propagation via the F2 region. Remember, I said that those SFI, SN 304A, and MUF US Boulder kind of tell us what bands might be open higher than 20 meters. Now, the ionosphere correlates best to smooth numbers, not daily numbers. So the numbers I put in the table are long-term numbers, not daily numbers. Just for the record, the daily solar flux can go from about 65 at solar minimum up to 350 at solar maximum. The daily sunspot number can go from 0 at solar min to 450 at a big solar maximum. And the daily EUV, that 304A parameter, can go from 70 at solar min up to 500 at solar max. So the table says what we need in terms of long-term solar flux, long-term sunspot number, and long-term EUV. For example, you know, weeks of those values, because that will open those bands day after day, not just occasionally. And you can see 6 meters, when we see the long-term solar flux index up around or greater than 145, you start looking for 6 meters to be open. That also translates to a smooth sunspot number of about 140. We're a long way from that right now. And long-term, the EUV has to be about 300. Remember, we were at, let's see, what was it? Let's see, that last, the EUV is what was at 99. So we got a way to go here before 6 meters is going to do something. Now that the MUF US Boulder gives us a pretty direct indication of what's going on. For example, it better be greater than 21 megahertz for generally the continental US to have 15 meters open. And of course, it must be greater than 50 megahertz for 6 meters. That all assumes pure refraction, okay? But there's some interesting stuff that goes on, and the digital modes has showed that to us. They can hear farther down into the noise, thus they can tolerate a bit more loss than a CW or sideband signal. And what happens is there's a mode called the above the MUF mode that appears to be the result of scatter. Scatter implies loss, and the digital modes can work when the MUF is somewhat below the operating frequency. You know, for pure refraction, we usually assume that the MUF must be at or greater than the operating frequency. But the digital modes, because they can hear farther down into the noise, can be good when the MUF is somewhat below the operating frequency. The other thing that helps is the amount of absorption is inversely proportional to the square of the frequency. So the higher in frequency, the less the ionospheric absorption. In fact, on 6 meters, generally 6 meter absorption is very minimal. So there's lots of loss that can be given up for the above the MUF mode. Now, to give you an example of how that works, there are some weak signal to noise limits in a 2500 hertz bandwidth for various modes. Of course, sideband is probably the worst. CW has a sizable advantage over sideband. These numbers come from the WSJTX documentation. They say that CW signal can be heard 15 dB below the noise in a 2500 hertz bandwidth. I made a measurement with my Omni 6 and a step attenuator, and I'm not as good as what they assumed. I'm sure there are people who are even better than minus 15. So yeah, I'm kind of around average, I guess, my ear to brain workings. You can see that FT8 has roughly a 6 dB average over CW. Of course, JT4 has a even more sizable advantage, JT65, JT9, and those other ones. So let's take a look at that plot on the right. So what it says is, if the MUF is right at the operating frequency, you don't have any more loss, and that's kind of pure refraction. Now, let's say the operating frequency is 2 megahertz above, or 2 megahertz, above the MUF. That says there's maybe about 18 dB of loss because there's some kind of scatter happening that completes the QSO. And since the digital modes can hear farther down into the noise and they don't have ionospheric absorption to speak of, it says it's very possible that's probably why the digital modes work so good and make 6 meters and 10 meters so good at solar minimum when sideband and CW doesn't have much of a chance. Okay. We talked about what those F2 region parameters need to be. And here's a slide of what the magnetic field parameters need to be. Of course, the K index is from 0 to 9, it's logarithmic. A index from 0 to 400, it's linear. BZ varies from about minus 200 to plus 50 in terms of its strength. Solar wind varies from about 1400 average up to 2000 kilometers per second when there's a pretty good coronal mass ejection or a high speed stream coming from a coronal hole. There's also GSR, geomagnetic storms, solar radiation storms, and radio blackouts. Those are 3 disturbances to propagation that NOAA classifies, and they give indication of what's going on. Each of those parameters ranges from 1 minor to extreme 5. So generally we want K less than or equal to 3 and A less than or equal to 15. We'd like BZ generally to be positive, a little bit negative is okay. We want the solar wind to be not too much greater than 400 kilometers per second. We'd like those GSR values to be around 1, maybe even 2. That indicates that the those disturbances are not hurting us too much. X-ray level, generally we want to be at A, B, or C. Generally we don't want M and X class solar flares. And Aurora Latitude, of course, depends on your location. The farther south you are, probably the less you have to worry about it. If you're up in Minnesota, probably got a lot to worry about. Now, although we'd like the magnetic field to be quiet, it can happen that a spike in the K index can enhance F2 region propagation at low and mid latitudes. One of the great examples was the 2018 California QSO party. And you can see on that it occurred, the QSO party was on Saturday, October 6th, and Sunday, October 7th. There's the MUF over the Boulder ionosonde, which is about halfway between W6 and my station, a lot of Midwest stations. On Saturday, the MUF was only around 20 megahertz, so we didn't hear much from W6 on 10 meters. But later in the day, about midday on the 7th, the K index spiked up, and you can see what happened to the MUF over the Boulder ionosonde. It went up to about 30 megahertz, 10 meters opened, lots of W6 contacts on 6 meters. Now, can this help 6 meters? On lots of contacts on 10 meters. Now, can this help on 6 meters? I think it's possible. I haven't seen one. Here's another good example. This is the Eglin Air Force Base in California. You can see there was a spike in the K index up to 5 and 6, and then the F2 region ionization got rearranged down in the southern tier of states where Eglin is, and the MUF went up to about 37 megahertz. So I think it's possible that a spike in the K index can get close enough to 6 meters that the digital modes will be able to work something, knowing that they can hear farther down into the noise and they can accept some more loss via a scatter mode. Kind of interesting stuff. And this has been known, this mode has been known for a while, this above the MUF mode. So just remember, we don't have to have an MUF of 50 megahertz. It can be somewhat less, and we could probably still make digital contacts. Space weather and 6 meter propagation via Sporadic E. Well, you've probably seen this plot. It's old data from 57 and 58, but it's still pretty valid. There are two times during the day when Sporadic E is best during the summer months, late morning, early evening. Also a smaller probability in December, but of course don't rule out other months. The probabilities may be low, but they do happen. We've had Sporadic E in April already, and I think there's been some in the months that kind of don't suggest that there should be much, but it happens. So, do elevated K indices cause Sporadic E? Well, here's a good paper from W3EP and WA5IYX. It's in March 92 QST. It's called 11 Years of Sporadic E. WA5IYX monitored 88 to 108 megahertz for 11 years. And he did it from 7 a.m. to midnight every day. He's in San Antonio. Now, on the plot on the right, the vertical columns are minutes of Sporadic E in the FM band. The dotted line is the 10.7 centimeter solar flux. And you can see he listened throughout a whole solar cycle. And the thick solid black line is the A index. So if you look at that and stare at it, you can kind of make a conclusion that Sporadic E doesn't appear to be strongly correlated to a sunspot cycle, because you can see that the minutes don't follow that dotted solar flux line too much. Now, also Sporadic E doesn't appear to be strongly correlated to the A index, because you can see that there's some good minutes in 82 and 84 when the A index was kind of high. So it just doesn't appear that sporadic E is correlated to the sunspot cycle and also to the A index. So I guess you don't have to worry about it too much. Here's another plot of sporadic E versus solar cycle. It comes from VE3EN. He does the solarham.net website. And I pulled data and plotted it. It's for sporadic E from W0, W9, W8, W4, W2, W3, W1, and some Canadian provinces on the East Coast to Europe, and how many days during the months of May, June, July, and August in those years that there was more than 5 sporadic E contacts. And you can see that, yeah, that kind of suggests that there is a correlation between a solar cycle and sporadic E. So not sure what to say. I think sporadic E is going to happen every solar cycle. Maybe it's a little bit better at solar minimum, maybe not. I don't know. I think there's a lot more data can be looked at to kind of make a conclusion. And if you guys have been on 6 meters for a long time, I'm sure you have your thoughts on this also. So what about solar flares? Do they cause sporadic E? Well, there was a recent posting to the Ham SCI reflector by KA3JAW. And as indicated on that plot, there was a C-class solar flare, 2.9. So it wasn't a real big C-class flare. It occurred from 2250 to 2310 UTC on April 23rd. What he noticed was about an hour later, there was sporadic E on the 11-meter band. I guess he was listening to CBeers or whatever he was doing. Like I said, it was an hour later, which puts it 0048 to 0108 UTC on April 24th. And he wondered if that flare had anything to do with the sporadic E. And one of the things I always believe is just because 2 events happen at or near the same time doesn't necessarily mean they're correlated. So I think a lot more study needs to be done. Of course, an important question is, what about those other solar flares? You can see there's almost an M-class solar flare before the C2.9, and then there's another C2.9 or so, and maybe a C1 something on the right. Did they have sporadic E? If you don't include a study of those solar flares, you could come to an incorrect conclusion. So I think the jury's still out on this. There's a lot of stuff we just don't know. And we're learning more and more each day. But of course, as we learn more and more each day, we find out we don't know as much as we really thought. So maybe there'll be some rebuttal on this post on the Ham SCI reflector. It'd be interesting to see that. Okay, transequatorial propagation. So transequatorial is primarily a north-south F2 region across propagation across the magnetic equator. There's a plot there on the right of the magnetic equator. There's the magnetic equator is the dashed lines there that kind of meander. Takes a dip in South America and then comes back up for Africa. Most of us in the continental US require a link to TEP, either an F2 hop or sporadic E. Of course, what makes transequatorial propagation go is the 2 clumps of high electron density on either side of the magnetic equator, maybe 10 to 15 to 20 degrees on either side, 10 to 15 to 20 degrees in latitude on either side of the magnetic equator. Note that you don't need enough ionization to refract the signal back to Earth. All you need to do is refract it enough to kind of follow the contour of the Earth. Of course, this is a rectangular plot, and of course the Earth is spherical, so you could see what happens on a spherical plot. Why are there two humps on either side? Well, it's called the fountain effect. And it's how electrons interact with the magnetic field and the electric field, the ionospheric electric field at low latitudes. It's a pretty interesting, and I've highlighted several common transequatorial paths from JA to VK, from Southern Europe to South Africa, like from the Caribbean down to deep South America. And also because of how the magnetic equator meanders, there's a path from the Caribbean to the Eastern Atlantic. So it's kind of interesting. Well, lots of people have reported it. So when does TEP happen? It's most prevalent in the late afternoon, early evening of the equinoctial months at high solar activity, but it happens, you know, our understanding of the ionosphere is statistical, so it may be a low probability, but if you're in the right place at the right time and it happens, well, good for you. All I can say is monitor, you know, the packet cluster spots, dxmaps.com, worldwide MUF map there on the right, PSK reporter, WhisperNet, RBN, reverse beacon network. On the dxmaps.com, they have modes color coded. I wish I would have grabbed one when there was TEP happening, but I don't think there is any that I could have pulled at the moment. So there's just a good plot on 17 meters. It shows, you know, lots of F2 paths happening all over, you know, North America, South America, and Europe. It's a hungry kitty cat in the background. That worldwide map comes from, well, I didn't put it on there, from KC2G. Just Google KC2G. And what he does is takes ionoson data. That's what the circles are with the numbers. Then he adds contour lines to tie those ionoson values together. And what you're looking for are two humps, the two clumps of increased MUFs on either side of the magnetic equator. I've kind of highlighted over in Europe, from Southern Europe down to South Africa. You can see that it may be hard to see, but there's some high MUFs right here, and also down here on either side of the geomagnetic equator. And that suggests that maybe you ought to start looking for TEP. And remember, I said that you don't need enough ionization to refract the signal all the way back to Earth. And the result of that is that the transequatorial MUF can be 1.2 to 1.5 times higher than the standard MUF. So interesting things can happen. And if you want to read about transequatorial propagation, there's on my website, you can read that. I'm sure there's lots of other places you can read it too. Now, just last November, there was a 2-meter TEP from HI to LU on 144.3 megahertz sideband at 2357 UTC on November 29th. So what was special about November 29th? Well, there's a plot of solar flux in extreme ultraviolet for all of 2020 and almost up to date to the present time. And you can see what happened in the latter part of 2020. There was the sun really hiccuped, lots of extreme ultraviolet from the sun. And of course that means the 10.7 centimeter solar flux was up also, sunspots were up also. And you can see where the 2-meter TEP happened, right when that peak occurred. So if you monitor, you know, long-term monitor 10.7 centimeter solar flux, you might be able to kind of take a wild guess at when TEP might occur. Okay, terrestrial weather in 6-meter propagation via tropospheric ducting. Just some basic stuff. There's a picture of the atmosphere in terms of temperature. It's divided into troposphere, stratosphere, mesosphere, and then the thermosphere. That's all characterized by temperature. And you can see that the troposphere, normally the temperature decreases till you hit the tropopause, then the temperature starts rising in the stratosphere till you hit the stratopause, and then it starts going down again until you hit the mesopause, and then it starts going up in the thermosphere. Now, again, normally the temperature in the troposphere decreases with altitude, but there can be temperature inversions. It can cause ducting. There's a picture of a typical inversion. The inversion depth is 200 meters in that plot, and that's kind of typical. Now, what that means is we can estimate the depth of the inversion to determine whether there might be a ducting probability. Now, I started with a plot in the ARRL UHF Microwave Experimenter's Manual, and they gave inversion depth versus frequency for 70 centimeters and 432 megahertz on up. I extrapolated below 70 centimeters to 2 meters and eventually down to 6 meters. And you can see that at 6 meters, you need an inversion depth of around 450 meters. Now, that's quite large, but it probably says 6 meters tropospheric ducting may be possible under extraordinary conditions. And of course, you can view inversions in radiosonde data, which are weather balloons. I used to have a website where you can do that, and I can't find where that is. Otherwise, I would have put it on there. But maybe you don't need that data because William Hepburn gives a tropo forecast. I'm sure he takes all that kind of data into account. This is from April 27th. That was from yesterday at 1800 UTC, and you can see where he forecast that tropo may be possible down in the Gulf area. The red and orange colors are the highest probability of tropo. Now, I don't know if these forecasts are applicable to 6 meters. You'd probably have to see red over the path you're looking at. If you have experience with these forecasts on 6 meters, I'd love to hear about it, either tonight or you can email me. That'd be great. How about terrestrial weather and 6 meter propagation via Sporadic E? Well, Jim Bacon, he's G3YLA. He was a retired BBC meteorologist, and he's taken a great interest in Sporadic E and tropospheric ducting. He gave a great hour-long presentation at the RSGB convention in October. It was virtual. He also presented at the Deep Dixie Contest Club on that stuff, and there's the URL that will get you to his video. What he's thinking is that Sporadic E depends a lot on our terrestrial weather down in the troposphere. And in general, he says that turbulence in the troposphere can generate an atmospheric gravity wave, an AGW, that couples up to E region altitudes and helps in the development of Sporadic E. So turbulence, jet streams is what he kind of focused on a lot. Thunderstorms, mountain waves, stuff like that can cause an atmospheric gravity wave, and that can couple up to the E region and maybe help in the development of E/S, Sporadic E. So there's some good videos to watch. Joe, K9LA, had an article in the November 2020 issue of CQ magazine. And he looked at winter Sporadic E-like propagation on 6 meters. And his conclusions were that local tropospheric weather has more ES effects than previously thought. And he said it's clear that simply looking at what the sun's ultraviolet and geomagnetic output is doing at the moment is just not sufficient to predict ionospheric variations. And he's got that right. He also had an article in 2017 QST in December, upper level lows and 6 meter sporadic E. If you're an ARRL member, and I hope you are, you can get the QST articles. And there's two figures from his paper. He's showing sporadic E happening, between the East Coast and kind of the Midwest. And he ties that to the jet stream and how E sub S, and he talks about how E sub S could be forming because of that jet stream and the turbulence there. So lots of good information there, and hopefully there'll be some more people, and I'm sure there's others out there. There's probably Europeans that are looking at this too, I bet. Okay, latest status of cycle 25. Well, I'm aware of 56 predictions for cycle 25. 50 of the 56 are for a below average cycle. That kind of says most scientists think that we're gonna have a small cycle. 3 are for an average cycle, 3 are for a big cycle, kind of like cycles 21 and 22. The one that has the most publicity is Dr. Scott McIntosh. And as of yet, I've not heard that the termination date for cycle 24 has been established. And the longer that goes, the smaller his prediction for cycle 25 will be. But still, we'll just have to wait and see what happens, that's all. Now here's one of the many predictions for a small cycle. This comes from the Solar Cycle 25 prediction panel out of NOAA. You can see cycle 24 on the left. There's cycle 25, their prediction in red. And of course, 6 meter propagation via the F2 region will be around solar maximum. But if you remember slide 8, said you need a smooth sunspot number of about 140 for 6 meters. And it looks like their prediction for cycle 25 will only be 120. But we got to remember, cycle 24 was about the same size as their prediction for cycle 25. And cycle 24 had F2 propagation on 6 meters around its peak in the fall winter months. So there are good things that can happen in the short term that we don't fully understand yet. So don't give up if cycle 25 turns out to be kind of small. Now, of course, if cycle 25 is bigger, there's going to be more opportunity for 6 meter propagation via the F2 region. And of course, the digital modes are going to give even more opportunity. So what's cycle 25 doing right now? Well, here's a plot of basically the rise times of cycles 19, 24, and 25. One thing we know is big solar cycles rise faster than small solar cycles. That's why cycle 19 is plotted. It's a big cycle, it rose pretty quick. Cycle 24 is plotted in red. And you can see it's a smaller cycle, so it kind of rose, didn't rise as fast as cycle 19. So what's cycle 25 doing? Well, we have 10 months of smooth sunspot number data right now. That's the green plot. And you can see what cycle 25 has done. All 3 of those plots start at the same 0 point at solar, at the minimum in the smooth sunspot number. And you can see that cycle 25 appears to be rising a bit faster than cycle 24. And of course, what's going to happen in the next couple months will be important, and perhaps it'll give us a clue on ultimately what cycle 25 is going to do. All I can say is we have to wait and see. It's just too early to say with any confidence what's going to happen. Cycle 25 could take off, or it could just kind of float along there, like at about cycle 25, 24 level. So we'll have to wait and see. So there's lots of space weather and terrestrial weather available for us. There's a lot we can, predict from that, but there's a lot we just don't know yet. And there's a lot that applies to HF also. 6 meters isn't really unique. How well all this data correlates to sporadic E in the short term is really the question. Hopefully we'll see more on terrestrial weather down in the troposphere and maybe get a little bit better ideas of what's going on. Forecasting transequatorial propagation is possible. You can use VOACAP for a path from the Caribbean down to extreme South America. And whatever the MUF comes out, you can multiply that by 1.2 to 1.5 and see how high it's going to be. Don't forget, for you guys and me, we still need a link to get down to the Caribbean to take advantage of transequatorial propagation. Now, the more serious method is to do ray tracing, and that's possible. But again, our model of the ionosphere and our propagation predictions is a monthly median. It's not daily. So we could miss what happens in the short term, and lots of interesting things happen in the short term. And I'm sure you guys can confirm that by some of your experiences on 6 meters. And all I can say is the best advice is to get on the air on a regular basis and see what's going on. I think the bands are open a heck of a lot more than we think. And contests bring people out, and it shows how well the bands are open. And, during the weekday, if you listen to our bands, generally not much on, that's for sure. So that's all I had, Paul. If anybody's got any questions, I can try and answer. If anybody's got inputs to help with some of the things I've talked about, that'd be great too.
Yeah.
Work. There we go.
Hey, I was wondering, I've got this picture here. I don't know if you can see it. Space Weather Services out of Australia.
You want me to stop sharing?
No. Oh, can you see mine? No. Yeah, no, stop sharing for a second.
Okay.
Let's see if this works.
Yep, there it is. Yep. Yep.
Yeah. So one thing I was chatting with Jay, K0GU, and one thing he brought up to me was, he said he looks always at this particular chart, this particular report out of the Australian government. Yep. Have you used this at all? Have you ever seen this before?
Yeah, it's very similar to that KC2G chart, except KC2G reports in terms of the MUF. This is in terms of the critical frequency. Basically, you can multiply the numbers on this screen by about 3, and that'll give you the MUF. Now you can see the signature of the equatorial ionosphere, right? The two blue areas, and they're divided by where the magnetic equator goes through. So yes, you can use that. Maybe you like that KC2G map better because it tells you the MUF directly. You don't have to, multiply.
Earlier this month, the folks lower latitudes were working 3D2 in Fiji, and also some ZLs. And at that time, this chart showed was getting a little bit more into the purple, purple and the closer to 14, and that's when they were going. This showed them going across the thing there. So I'm just interesting because I didn't realize what this particular chart, this particular report was doing, but this does like the last 7 days. So it's kind of a cute little thing if you're looking at the Pacific.
No, I think it's more real time than you think, unless there's the last 7 days condition.
Well, it says here the last 6 hours here.
Yeah.
you can actually, I don't know what loading the, this is the automation. Here you go.
Yeah, there you go. You can have a movie. Yeah. You can see where Transequatorial propagation might have occurred right there.
Exactly. Yep. You can see that purple in the middle there.
Yeah. And of course, the purple 12 and 13, you multiply by 3, you get 36 to 39 megahertz. That might be enough for the digital modes on 6 meters.
That's what I'm thinking.
Yep.
It's just another source I came across. Yep. I wondered if it was.
Yeah, there's lots of stuff out there.
Absolutely. All right, I'll stop sharing.
And of course, what this also tells you is this takes into account how active the magnetic field is too, because that'll reduce those F2 critical frequency values you see on the map. So it's a direct indication of what the ionosphere is really doing, taking into account geomagnetic field activity, maybe solar flares, stuff like that.
Right, exactly. Let me see if I can figure out how to stop the share. Oh, there we go. Yep, there we go. We're back to.
Yeah, that was that's pretty much a real time too. Ionosondes generally report every 15 minutes, so it's pretty darn close to real time, which that's good.
Yeah, if anybody wants that link, just drop me an email, and I'll send you the URL.
Paul, what I also plan to do is send you a PDF of my slides too, and you can do whatever you want with them. So.
Yeah, that'd be great. I'd like to put that in our files section on the group IO. That way people can look at it.
Okay.
So Carl, I'm kind of surprised there isn't a better understanding of sporadic E because, there's on 6 meters in particular, because there's, quite a bit of operators on 6.
Right.
We have, sometimes just monster openings that are rather amazing. Mm-hmm. You'd think you'd be able to correlate that with something.
Well, the stock market, maybe? Oh, no. Okay.
Well, maybe.
No. Well, remember now, our observations just tell us the basic morphology, whatever that word is, morphology, the statistical pattern of sporadic E. What we need is more physical investigation of the physics up there, what's going on. And that we just don't understand. Why? I think we know that meteor debris is probably the source of electrons, but how do they truly get clumped together or into a thin layer? And we just don't understand it yet. So, well, just think, when we quit calling it sporadic E and we call it E, then that probably implies we know what's going on, right? Yeah. Or instead of sporadic E, we call it absolute E or something like that. Yes, Lance.
Carol, one thing I have noticed more often than not is that after a big auroral event, as the K index is dropping down, if it drops down rapidly, we almost always have sporadic E to the south. At least from Montana. And I think other people have seen this phenomenon also. Yeah. So that's a real good thing to watch, at least for us out here, because we're not like those guys east of the Mississippi who always have sporadic E no matter what on 6 meters, like you do. It takes a lot for us to have it.
An interesting comment is that if you look back at some of the old sporadic E statistical patterns from Smith back in the late 50s and look at, the GPS occultation data now, sporadic E is a little bit different. It's not in the same places as much as it used to be. This last summer wasn't, well, maybe I just need to get on 6 meters more. But yeah, if you're in the right place at the right time, that's great.
The last couple days on 6 meters, I noticed the propagation was only allowed east of the Mississippi.
Okay.
I mean, literally, it was a hard line.
Yes.
All those FT8s.
That's not just the last few days.
Yeah.
It's been forever.
But certainly the last few days.
Yeah. I've noticed when there's storms, when there's thunderstorms, like down towards in the southeast, we get some sporadic E just around that same time, and or if it's a big storm coming in from the northwest, like through Washington, Oregon area, I've seen sporadic E start pick up a little bit when those things start happening. It's just like when these big things happen. They get lots of tornadoes and lots of high energy. It seems to start off some of the sporadic E I've seen.
Yeah, I think we have a lot to learn about what happens in the troposphere.
I think Mike W3IP, you're going to say something?
I was just going to say that one bad thing is there's been a trend in the last few years for higher and higher noise floors, from all of the electronic junk that's out there. And that's probably biasing things a bit in the wrong way as well.
Mm-hmm. Yeah. So has anybody claimed to have had a 6 meter tropospheric ducting QSO?
Well, I did have a contact in January with Australia on 6 meters.
Okay.
Might have been Australia and New Zealand. And the opening was, Paul will remember this, the opening was about maybe an hour. By the time I told Paul about it, he came in at the very end and just missed making a contact. Right, Paul?
Yeah, I had a lot of noise that particular night too, because I hadn't had the power company to fix it yet. But I looked at the flags that were across Australia, and I had flags all the way from one coast to the other coast that heard me on FT8. So, but no contact.
Carl, you might be interested to know that in the early 1960s.
Carl?
Jim, are you talking?
No.
I think Jack had a comment, and then
okay.
I want to comment on the tropo question on 6.
Okay.
In the early 1960s, K9EID, Bob Hyland and I were running across Missouri into Illinois, and we were trying to correlate the S-meter readings, if you will, with the weather. And we didn't really prove a whole lot. But the other thing was that I made the very first 6 meter single sideband contact 2-way between Iowa and Arkansas over a storm front that was laying east to west across Missouri.
Oh, okay.
Yeah, and my one experience with 6 meter tropo, it was my first, there was a big tropo opening across the Gulf Coast. So I was working 2 meters and 432 into Florida from here in Texas. And somebody asked me to try 6 meters. I think they were in the Atlanta area. And this was all single sideband at the time. And we did manage to make the contact, but it was extremely weak. You know, I knew what call sign to expect. So I think I heard it better than I probably should have. But I think it is very rare.
Yeah. But it happens, and if you're in the right place at the right time, it's great.
Yeah.
Carl, one thing that you didn't touch on is this what they call Sssp propagation in the summertime. So what really I think is just, it's a chordal skipping along the geomagnetic field lines, and kind of like TEP, only it's along the field lines. And if we do have the magnetic field lines, like from the United States over to Japan, or from the East Coast over to Europe, and I think a lot of the multi-hop that they find is that chordal hopping along those lines. And we find these huge 6 meter openings every summer to Japan. And I usually am out in the cold because you need to have a good, strong E cloud to launch your signal into this skipping phenomenon. And usually I don't have anything off the coast of BC to launch my signal, but guys down in Colorado and Oklahoma and Texas, all the E clouds are always over the central part of the United States, and they have no problem launching their signals right up over top of me and skipping back over to Japan. So that's something to watch for in the late afternoons.
Yes. Jim Kennedy has a paper on that. I don't know if you've read it, but I'll when I send the presentation, Paul, I'll also include his paper. And he talks about SSP. And, he's retired. He's in Florida now. He's not KH6 anymore.
Yeah, Peter, you had a comment there, PS?
Yeah, I was fascinated by this. I think it was the G station that had done the talking about the gravity waves and the turbulence creating gravity waves and creating E clouds. Yep. I hadn't heard that one before, and I look forward to getting a link to that so I can watch that.
Well, it's on the it's on my slide. So when you get the slide deck, then you'll be able to go to that. Yeah, he's good.
Well, when I was back in Ontario, I guess I used to work a lot more E-skip. Yeah. Well, I haven't really even tried here other than a bit on 6 meters, but it was just far more prevalent on all the bands back there, even 2 and 220. I can correlate the first 220 E-skip contact I made directly with a very strong thunderstorm that was sitting over, I think it was northern Arkansas or northern eastern Oklahoma or something. I can't remember exactly. The next 220 opening, which was way better, there were no thunderstorms. So, which was kind of weird. The other thing is that thunderstorms move west to east. And yet if you're tracking E-skip openings from Ontario, southern Ontario, they move east to west. Yep. So somehow, I mean, we've been chasing this thunderstorm theory for a long time. But based on practical experience, I'm not sure really there's anything there.
What you have to remember is it's not the thunderstorm itself. It's the thunderstorm does something that couples up to the E region altitudes. And I don't think we understand that very well. So
I agree. Maybe this gravity wave thing, maybe that's the key. I don't know.
Yeah. There's lots of research going on in that, mostly for HF though, but I'm sure, the knowledge that comes out of HF will be applicable to 6 meters. What is everyone's feelings about sporadic E versus a solar cycle? Someone had their hand raised. Ed?
Yeah, I just wanted to make one question. This propagation that we're getting down to Australia, New Zealand, and 3D2 recently, is that tropo? We need a sporadic E link to get into it, and they need a sporadic E link to get into it from the other end.
Yes. Yeah, I've seen that specific scenario happen. But you have to remember, the ionosphere is most robust in the equatorial latitudes. So if the path stays at low latitudes, that gives you a heck of a lot of better opportunity. And I'm sure you guys have seen it. I'm up here in Indiana. I see the southern tier of states working all kinds of stuff, and I don't hear a thing. And the MUF is higher as you get closer to the equator.
Yeah, we see it here too. We see stations in southern New Mexico working all over, and we're not hearing anything.
Yep.
Yes.
Yeah.
Yes.
You should be here.
Yes, Jack. Arizona too.
So what about ES versus a solar cycle? What are your thoughts on that?
Maximum E-skip with low sunspot flow cycle.
Okay. There might be a tie, and it's probably something to look at even deeper. And
Carl.
Yes.
In the HF propagation book, the first edition, there is a graph. I think it came out of Sweden, where they had the number of hours of E's versus the solar. I think it was sunspot numbers or maybe solar flux, and it was a total reverse correlation. When sunspots were up, the E's were down, and when the sunspots were down, the E's were up.
Okay. What book was that in?
That was in the HF propagation book, which I think you just were co-author.
Oh, in the CQ thing. Okay.
Yeah.
Yeah. What you're talking about, of course, is the corollary to Murphy's law. When you think you've figured something out, somebody will come along with data that says, no, it's all wrong.
You looked at the data from Bob, K9LA. He's got a lot of stuff from, propagation to Europe.
Yeah, I'm sure he would. That's like VE3EN and his data. Yeah, it was mostly the East Coast to Europe. Yep.
Yes.
Yeah. And it's always a bell curve.
Yes, for the months. Yeah. And speaking of that, Jim, G3YLA showed a plot, two plots. One in the summer months showed that sporadic E happened in the late morning and early evening. But then in April, he had data which said it's not a dual mode there in April. It's more flat. So there's probably other stuff going on that we just don't understand.
Well, that's great, Carl. You've been super here tonight, and I really appreciate you spending this time. I know it's late in the East Coast there. It's like after 10 o'clock. So thanks again for sharing your expertise with us, and also your slides and in the video now. So hopefully we'll keep in touch with you. And again, thanks again for all your help.
No problem, Paul. It's a good group you got there. And yeah.
Yeah, well, next month we're going to be doing SDRs and
stay active.
Doing the hardware and the software side.
Okay, great.
All right, guys, thanks again. Any other last minute comments? That's it,
Paul. Yeah, thanks a lot.
Thank you very much,
Thanks,
Carl.
everybody.
Thank you.
Thank you very much, Carl.
You're welcome.
Thanks, guys. Nice to see everybody. Bye-bye.
You again.
Carl.
Don't you guys.
Yeah.